big data and just introduction of the big data and data analytics. Then the two managed to address the problem of using the big data. We are going to use Hadoop, the big data system. So we learned about what is a Hadoop, the concept of a Hadoop, especially the HDFS, the Hadoop distributed file system. So why don't you remind, we have the master node and we have the slave node. The master node is the naming node. Okay? There is another naming node, secondary naming node, which is not backup, which is not standby, which is just helping the housekeeping job of the naming node. Then we have the many data nodes, the slave node. Each node has the HDFS. So when we upload the file from local client, it will be copied. There will be a minimum 3 copies. Okay, depending on how to set up your Hadoop system. There will be the 3 copies. Default the 3 copies. Then it will be located along the server. Okay, that is the main thing. Also, each copy of the data will be based on the big. The data block usually 128 megabytes size. Okay. So you can set it depending on the configuration. It can be the 64 megabyte or either the 128 megabyte. Even it's bigger than that. So it depends. But anyway, that's much bigger than other traditional database system or other file system, the block size. So that is what we have learned before. We learned about the next thing is the MapReduce. So we have 2 core components in the Hadoop system. One is the HDFS plus MapReduce. So what is the HDFS? It's a file system. It's a distributed system. It supports the hardware. Not hardware, it supports the distributed file to separate or to get the benefit of the cluster system. Then after you store the big data along the server, we should be able to access such a data parallel. So that is the MapReduce programming. Or MapReduce is more like the framework to process such a big data. Okay, they are coded by the Java, so we will learn how to program, how to learn the MapReduce. Benefit of using the MapReduce is most of the parallel programming or distributed programming are very complicated. You need to consider a lot of things. But MapReduce programming actually takes care most of such a housekeeping job. The other workload only you can focus on the algorithm. Okay, that is the benefit. Then plus we have several components such as HBase for the database structure, and Hive, and Pig, and UC, and some other. Okay, so these are called Hadoop ecosystem. So in this semester, we are going to use the Hadoop ecosystem to manage the big data and to process the big data. Okay, and in addition, if we have a time at the end of the semester, I'm thinking about the use Spark, which was not discussed in my previous class, previous semester, but this time the Spark is one of the very popular the Hadoop ecosystem. So if we have a time, I will add more content. Also, fortunately this semester we will invite one of the professor in the Hadoop the community. He is very well known. I think I already emailed you guys. Then from the USC, he is offering the Hadoop class, and also he is doing research regarding to the big data analysis using the Spark, the system. Okay, so that is the overview, review of the last class. Then So today we are going to mainly discuss about the MapReduce, including this week, next week, and next 2 weeks, so 3 weeks. So we will learn about the MapReduce. I updated the 4 files, the MapReduce, the PDF file, and uploaded to the class website. So if you already download all the file, why don't you replace the file? So I add the v2 version 2, the MapReduce file. I'm going to start in the middle first to briefly overview of the Hadoop cluster. So as we discussed before, we have the master node and many slave nodes. Okay, and then we have the naming node as the master node and the data node. So in terms of the daemon is a process or service. So there's a naming node, daemon, process. So coordinate and manage everything. And each node has the data node. Regarding to the MapReduce program, there are 2 different types of the architecture. So one is the MapReduce version 1, MRV1. It's a classical way. Okay. Still nowadays, many of the company use the MR, the MapReduce version 1. Also, last time when I discussed about the overview architecture of the Hadoop, I explained the architecture based on the version 1. Okay. Then nowadays, after Yarn, yet another resource manager was released, then the current system is called the MapReduce version 2. MapReduce version 2 is based on the resource manager. Okay, Yarn is not the MapReduce. It's a different on top of existing HDFS and MapReduce the framework. So Hadoop add the resource manager. The reason is that first, it's a very limited because they are using the MapReduce and the HDFS up use a lot of memory. So it is limited by the memory resources. So is there any other way to increase the performance? So they try to manage the available resource along the data node. So this is what we learned the last time. There is a version 1, MRV1. So current version is MRV2. That is based on the resource manager. It's another service, okay, to manage the resource. Why? Why? So to increase the overall performance. So it can process, for example, the 2 times more the data. Okay, and performance is better. So this is a basic architecture. So instead of the job tracker. So we have the job tracker in version 1 and task tracker for each data node, right? Instead of, in addition to that, we have the resource manager. So resource manager is another, it can be running on another node or it can be running on the naming node. So then this resource manager receive the programming MR, the programming request from the client, then communicate with the application manager. So there's one resource manager in the cluster system. Then one application master service per job, per program, per application. Then this application master communicate with the other data node to balance or to maximize the resource. That is called the container, which is not here. So container. Then on top of that, there is the new MapReduce, the library. So slightly different. But when you learn the MapReduce program, so it's not much different. So basic, the concept is not much different. So I'm not going to differentiate version 1 and version 2. Our lecture or the training will be based on the version 2. So you don't have to worry about too much. In case if you have the version 1 library, then it can be compiled and it's running without any problem. Okay, so in the head of system, when we call the job, what is a job in operating system? It's a process, right? So in Hadoop, it's called the full program or application. For example, we have the big data for the Google search history. So I'd like to sum the keyword by the flu, for example. So I'd like to sum by the month. So January, how many? The keyword that include the flu. February, same thing. The March, same thing. Then that is our program you implement, whatever that is. So that is one full program that is called the job. And this job will be distributed by HDFS, the data node. Okay? So that is the task. And each task is called the instance. Then, so we have, as we have seen the last time, is the version 1, the architecture. It one, the job tracker and task tracker, task tracker, task tracker. Even though we are going to use the version 2 library for the MapReduce programming, but we are going to use this architecture. We are not going to use the resource manager. We are not going to set up the resource manager. That will be more complicated to understand pure part of the MapReduce. However, when you implement that one, if your admin or if yourself set up the resource manager, you don't have to change anything. Just run, then resource manager will take care of the job, your program. Okay. So, for example, you will learn what is this one during the lab after this lecture. Then submit the job. This is uploading the file, your big data. Upload the file. Then from your client, you can submit the job through the job tracker. Okay. In case of the resource manager will take care of this one. Okay. But we are not going to use the resource manager, so job tracker will run the task. We will use the task tracker to create each task. Then, one of the benefits of using the MapReduce is locality. Locality means we have the data block here, another data block here. So each map task will running on the same node, okay, where the block is located. So it's a locality. Then you don't have to worry about what is the map, what is the reducer yet. Okay, we will discuss today. Then the reduce job will be done. Then finally it will be returned. But in case we use the resource manager will take over the job from the job tracker. Okay, this one. But we are not going to set up the resource manager yarn in our implementation. But your programming itself will be based on the version 2. Okay. Okay, then that is the overview of the HDFS. Then we'll start the MapReduce program. Okay. I'd like to use this example. It's frequently used. Set So let's say this is our big data, even though this is small. let's consider this is a big data. So we call this file as a my data dot dat whatever. Okay. So our goal, our job, our problem is we try to count number of words. For example, how many the here? 1, 2, 3, 4. Okay. And how many cat? 1, 1. How many set? 2. So this is our goal. Okay. I know. If this is not the big data, we can just implement by simple programming, right? We can read, and whenever we have a new word and keep it in the array, then the increase the value. That's it. But what if this is the 1 petabyte size? We don't know how many the word here, so it will be. There might be the optimized program, but still takes a long time. So we try to use the benefit of the MapReduce. MapReduce is basically, as name implies, mapping and reducing. Both of them use key value format. Only key and value. But as I mentioned the last time, don't be confused with the key is primary key. Okay? It doesn't matter whether this is the unique, this is the duplicate. It doesn't matter in big data system. Key is as long as you can compare. Compare means what? You can make the order. Like the number you can compare, right? And string by string you can compare. So as long as you can compare, that will be key. Okay? So first there are 2 steps. Mainly 2 steps, but details more than that. But mainly 2 steps. Mapping is we try to map. Map what? Mapping key and value from the data. Okay? So how can we do that? So first, when you read the data using the MapReduce, what is a MapReduce? It's a Java library. Okay? Java library, which means there are a lot of classes. So you should be able to use such a class that I'm going to introduce. So in the MapReduce, the Java class library, there is a specific library, text input stream, for example. Text input stream read the data input file as by new line. What is a new line? Like this one. In terms of Unix and Linux environment, this is a new line character. Can you see this one? Actually, you cannot see it. It's a format. It's a white character. It's an invisible, but it's inside the file. Like this one. Okay. What about the Windows system? They use line feeder. Okay, it's a white character also. Okay, Unix and Windows, they are using different the file format. So because the header is based on the Linux environment, there is a new line character every line. So for each line, okay, from each line, we will map the key and value. You can actually map as this way. What is the line number? It's the first line. And what is the value? The cassette, like this one, key and value. It may be possible, but here I'd like to directly take out word by word first. Okay? So I'd like to map this one first. When you read the data, this data is line by line, always starting with line by line. Then for each line, I'd like to assign the first word. This is a map. First word is the okay. Then what about this one? Is a key or value? It's up to you, depending on how to design your key and value. So I'd like to use the first offset or line number you should count, right? You need to have additional variable, right? 1, 2, 3. So instead of the line, number of line, I'd like to use offset. Offset means, what is the offset of study? We do not have here. It's a 0. 0 has the cat, set, the map, key and value. And next one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay? 23, the next one. So, key and value, key and value. Then, our goal is what? Count number of words. So, we can segment. How can you segment?
/2.
You can use
White space /2.
regular expression or any other library that support segment delimited by the space, the tab or comma. Some of the languages provide such a function, but mostly we like to use regular expression. So that is one thing. You should be familiar with. If you wanna implement some data analytics or the big data analytics or data processing, the regular expression. Regular expression is the kind of rule or data structure to handle the text data. It can be implemented by the Java. So most of the high-level languages provide a function or library or class. Okay, so Java, definitely yes. So using such a regular expression, so we can take out easily by word. Okay, then we can have, next time from here, we can have the comma 1. And from here, cat, comma 1. We no longer need this key value. Okay, because our goal is number of count. So we need how many dog is 1, and how many cat, how many set. And from the next line, how many dog? 1. And addbar 1. Key in this time, what is a key? It's a word. What is a value? 1. All 1. The key value, key value, key value. Then, next time what we can do is, we can combine the, right? So, we can how many the? How many 1? 3. And also we can, the same time to count the, we need to sort the data. So, we can shuffle, but how to shuffle? By sorting. It's called the shuffle and sorting, sort and shuffle, but either of them. So, which means, so we need, first, which one is the smallest one? The A, algebra. AARDVARK. 1. And next one is, actually we need to find from here, it's a cat. How many cat?
1.
So 1. How many, the next?
Map.
So map, maybe, next one. And
Sofa.
the, it's a 3.
4.
And next. Sort by the key, and we can count number of them. Somebody may be curious. Why don't we add up all of them at the same time? If the data is small, you may not realize the difference, so you can add up. However, when you have big data, really big data, to add up all the value, it takes a long time. We can just line up, okay, without any operation. This one does not require any operation, okay. This is called mapping. Then this one sent to the reducer. Reducer, main job of the reducer is reduce, narrow down. In other words, you can process the data like this one. How many? Algebra is 1. Yeah? How many though? So you can add 1, 1, 1, it's a 3. Something like that. Then output will be written to the HDFS. That's the main process, main idea, just idea. I don't explain details yet. Main idea. What is a map? What is a reducer? As you can see, the MapReduce program main part is how to design key and value. Okay, there are many different ways, and also how to implement the algorithm. What is the algorithm here? It's just a sum. But real life system is not that simple. Sometimes you need to do something very complicated job here. Okay, like the average or standard deviation or something other analytics, regression in the statistics. Okay, so this is called word count program. Kind of hello world in MapReduce. Okay, so basically using the mapping and reduce, so we can process such a big data with the benefit of what? HDFS. So we will see details how it works. Okay. Here, so this is input data. Input data will be stored at where? HDFS. Okay. In case this one is bigger than 128 megabyte, it will be block by block segmented, and each block will be copied 3 times. Okay. So first, the mapper. Mapper is, as I explained here. So first, the record reader is the first file, text file, the string, the class. And the text file string, the class, there is a record reader class. Record reader can read the data by line. So 0, this is offset, and this one. 23 is the offset. How many bytes from the beginning? Then this is a line. And 52 next, and so on. Then using this one, we can have the first key and value. Okay, that is a mapper. So mapping is a segmented map based on what? Blocks. Okay, this is from one block. This is another block. Okay, for example, this is 128 megabyte located in the first block in the data node 1. Okay, this is 128 megabyte, so it's located another block. Then we will have 2 mapper. Okay, so it's a locality. So each block has their own mapper. It's identical, but it's executed by the job tracker. Okay, then we can have parallel processing. Okay, that is the idea. Then each mapper will extract the key and value. Key is the word and how many? 1. Okay. Then this is you can see the different node. Okay. So for example, we pretend the 2 node is 128 megabyte. This is another block, something like that. Then mapper, we will get this one, and then this is the shuffle and sort. Shuffle and sort. Every time I got confused, sort and shuffle and sort. Shuffle and sort means, so by sorting the data, we can, actually it's not add up, it can just combine. We don't need any other operation. Somebody keep asking, why don't we add it here? that will be simpler. Okay? But if we implement such a operation, when we have a big data, it will take a long time. However, there is a way to reduce the job of the reducer. So, which means you can actually the program, you can execute the sub program of the reducer earlier. So you can reduce the overhead of the reducer by executing earlier. We will see later. Okay, that is called the partitioner. So, but before that, so we can have the. Don't forget this. The key is sorted. Okay, by the alphabetical order. Then there is just combine. How many one? One. And in this case, on here and here. It's just a combine. And the how many the is a 4. Okay, from one node. Then this is the another block. So another mapper to do the same thing. Okay, they are located in the different nodes, so they cannot communicate. They cannot combine, sort together. It's a separate node. Okay, parallel processing. Then after you finish this one, this is called intermediate form. It's not final form, it's an intermediate key and value. Intermediate key value will be sent to the reducer. Okay, in this case, how many reducers? We have 3 reducers. So in your program, in your configuration, you can set up how many reducers you have. As a default, it's a 1. So which means all of the intermediate form will go to one node to be combined. In here, for example, 3. So the A through M are aardvark, cat, and mat are in the first reducer, and elephant, mawat, the second reducer, and the others are third reducer. Then finally, this one will be processed. Process means the adder for this one. Okay, then this is output, this is output, this is output. You have the 3 output file. Finally, you can combine all together to get the final output. This is called sometimes sum reducer. For example, flu. The Google flu analysis is nothing but this one. Okay. Any question? Ideas are simple, but not that simple to design. In real life system, which one will be key, which one will be the value? Because if you do not know about the relational model, it's easy to understand. But everybody, I was the same. So when I try to understand the first time the key value in the MapReduce programming, always when I decide the key, always I'm thinking unique and non-null, something like that. Really. So it will be the same to you. So, but this is not the primary. It's just a comparable data. As long as it's comparable means like the integer. You have an order, so you can make the order. You can sort the data. Doesn't matter whether you have the duplicate data or not. Okay, like the here is another, another. Doesn't matter.